Good afternoon, everyone, and welcome to the course on blockchain technologies. So this course will be starting from today, that is 1st March. It will continue till 1st of April, covering both the theory and the implementation part of blockchain. And this course is carried out by the Capacity Building and Research Entrepreneurship Center in Artificial Intelligence, Big Data, and IoT under the Center for Skill Development and Entrepreneurship at UIET, Punjab University, Chandigarh. And this project is sanctioned by the Ministry of Electronics and Information Technology, Government of India. The principal investigator of our project is Dr. Mukesh Kumar. So he will be briefing you certain things about the course and how the details of the course and what are the things that you need. A brief introduction to the course. So I'm transferring you the rights, sir.
Okay, thank you very much, Sakshi. So am I audible, Sakshi?
Yes, sir.
Okay. So first of all, good afternoon and welcome you all to this inaugural session for the 1-month workshop on this blockchain technology. I congratulate you all for becoming part of this program. So let me brief you about the project. This project is sanctioned to us, or you can say to Punjab University Chandigarh, by Ministry of Electronics and Information Technology. And at the end of the year 2020, means 2020, the main aim of the project is to develop skills or to enhance the skills in the technologies related to artificial intelligence, big data, and Internet of Things. Along with the capacity building, the next branch is to enhance the research facilities which are available at Punjab University and to make it available for the youth in and around us. So the overall project is about two things. One is the capacity building and the next one is the research entrepreneurship. Means we need to come up with the innovative ideas, and the innovative ideas are required to be converted to products which are usable, which are going to make the life of others easy. So with this aim, we started the execution of programs, and this is the fifth in that queue. We have already conducted 4 1-month programs. The information about all 4 programs is already available on our website. Their video links, their introductory speeches, means each and everything was recorded very well and was put on our YouTube channel. So you may directly go to that YouTube channel, or you may follow our website also for having information about the courses. So this is the 5th activity under this center. So we really hope that our experts will be able to disseminate at the best of their level, and you will be able to gain a lot of things, lot of knowledge out of it, and maybe you may come with some products, some innovative ideas after this workshop. So this is our sole aim for this workshop, for this program. And the next thing we wish to share is that we always follow a practice of putting all the contents covered within a day on our YouTube channel. So this workshop will also be following the same. Means to say that each and every day, suppose our session concluded at 5 p.m. today, then by 10 or by 11 p.m. the contents covered in the form of video lectures will be uploaded on our YouTube channel. So all those who may be finding it difficult or you can say finding some problems in internet connectivity, they may later look at those videos and may complete their goals. So this is the unique practice we are always following while conducting these courses. And next thing that I wish to mention is that me as a project investigator and associate professor at UIT Punjab University, and my team that is being led by Sakshi Kapoor and 3 or 4 other persons are always there to help you out. If you feel anything, if you are facing any problem, then you may directly call upon Sakshi or just intimate me also. We will try to resolve it as early as possible and will make you comfortable. Uh, so the overall structure of the course is going to be like that. We'll be conducting a short theoretical session and then it has to be followed by the practical hands-on sessions. And each day we'll be having a quiz of 10 to 12 questions, uh, which through which we will be evaluating you. Or you can say not exactly the evaluation, but we will be having an idea about how much you are grasping. So a quiz will be there, not maybe from today, but from tomorrow onwards, regularly that quiz will be there at the end or at any intermediate stage. So the quiz attempt is compulsory for all of you. Along with this, you need to mark your attendance daily. An attendance sheet or attendance link will be circulated within the 2 hour course. So you need to mark your attendance in that list every day. So we are going to look at your attendance also as well as your scores that you achieved in your quizzes while deciding upon your certification process. So next thing is that always feel free to contact us and to end this and by keeping it very short, I wish you the best. May you gain the maximum out of this workshop. So best wishes from my side. Uh, Sakshi, over to you.
Thank you, sir. And now for today's session, we will be having Dr. Neeraj as the presenter for the course, and he will be taking your sessions for the day. Dr. Neeraj is currently working at UI at Thapar University. He has done many research papers and many researches, mainly in the area of IoT and big data, which are including VANET and CPS. He has done his PhD in CSC from SMVD University, Katra, Jammu and Kashmir, and he's also working as a he's currently as postdoctoral research fellow in UK, and he's also visiting faculty over there. He has published many research papers, including major which includes in IEEE. Some of them are in IEEE transactions on industrial electronics. Some of them are on information forensics and security, and some of them are on IoT journal. These are just a few to say. There are many of them which there are innumerable of them which are beyond our scope to even grasp that how many papers he has published. He has guided many research students in the field of MTech as well as in PhD. So over to you, sir, so that you can start with the course.
Hello, good afternoon to all of you. So I hope I'm audible to all of you. Is it okay? Yeah.
Yes, sir.
Okay, great. So first of all, I would like to thank the organizer of this workshop. This is blockchain technology. And I was very excited when Mukesh approached me and says that he is very eager to conduct this workshop on blockchain technology and IoT technology on this. So I would like to congratulate Mukesh to make this arrangement for knowledge dissemination, because this is a unique platform where we can learn and enhance our skills, and where we can have knowledge share with each others at different platforms. Why not in the era of this IoT and blockchain technology, which is one of the we can say emerging technologies nowadays, both at undergraduate level, PG level, and PhD levels. So this is a very good initiative as far as Punjab University is concerned, that it provides a unique platform to the participants where they can sharpen their skills in the new emerging technologies like blockchain and IoT. So basically about this particular course, so we are the two instructor for this particular course. So one is myself, and second one is Sudeep Tamar from Nirma University. So both of us uh, conduct this course, that is blockchain technology from theory to implementation. So most of the times, uh, you see that most of the times people are mostly talking about blockchain technology as a theoretical concept, but how to implement this technology in a particular scenario itself is one of the key areas that we will explore in this particular course itself, like how to construct the smart contract for different applications, and how to design your own cryptocurrency which can be used in different applications. And then also we will start with how to use different use cases for blockchain technology in different applications, etc. So today we will have the brief discussion on this blockchain technology, its basic components. So although Sakshi has already told both of us, but to be very frank, myself, Professor Neeraj Kumar, so I'm working as a full professor in Thapar Institute of Engineering and Technology, and I have more than 20 years of experience and with expertise in blockchain, machine learning, deep learning, and network programming. So as a part of this, I have more than 60,000 citation with current H index of 68, and I have published more than 400 SCI publications in top tier journals in these areas, and also have executed 6 crore of government funding in different projects, and authored 10 books which are edited or authored in the from Springer, Elsevier, and IIT, and also have 15 PhD students with 35 ME and Tech students. And I have conducted more than 100 FDP, STCs, short-term course training on blockchain, deep learning, and machine learning. And I'm editor of various journals. Similarly, my other partner, who is also the part of this course, that is, he is Dr. Professor Sudeep Tamar. He has also more than 20 years of experience in different universities. He is a visiting professor in Poland and in University of Romania with 3,600 citation and current H index of 35. And he has also more than 200 publications in SCI journals with 24 books, which consisting of authored, edited, and conference proceedings. And he is editor of various journals, supervise ME and PhD students. And more interestingly, we have co-authored one book that is called as Multimedia Big Data for IoT Applications, which has 3.7 million download, and he has been invited speakers in various conferences. So this was a brief introduction of both the instructor for this particular course. And apart from this, uh, we also have certain other, we can say, developers who will design you, who will expertise you that how to create your own blockchain using Python, and how to install Anaconda, and then how you can use Anaconda for deploying your smart application using smart contract, etc. So as far as the resources are concerned, so uh, most recently I have the textbook published on blockchain technology with Elsevier. You can check the resources on this link itself. This is the newly published book, and also this book is also there, that is from CRC publisher. So these two books, you people can refer it out in your course curriculum uh, for the blockchain technology to be used it out. So today, most important part is that we will discuss about the basic components of blockchain technologies, and what are the basic key components of blockchain technology, and how this blockchain technology has certain distinctions with database and blockchain ledgers. So most of the times you people are wondering whether blockchain is a database and how this blockchain can be differentiated with traditional database and blockchain ledgers, which are used to store the information in the form of blockchain ledgers itself. Then most important part is we should also be very much frequent about cryptography with various hash functions and digital signatures which are being used for construction of blockchain technology. Then what does it mean by the consensus components? That is, consensus component is consensus protocols are there, and how these consensus protocols can be used in blockchain consensus algorithms. And then what is the structure of a blockchain, like what how many different types of blockchains are available. Then uh, these types of, I mean to say here, scenario can be used uh, for finding out different types of we can say blockchain structures to be constructed as far as private or public blockchains are concerned. So we will start with the first part, that is introduction about blockchain technology. So it is important to distinction between basically three things that are commonly muddled up, namely first is Bitcoin currency. So how this Bitcoin currency uh, is there, and what specific blockchain that underpins it, and idea of blockchain in general. So most of the times people are confused about these terminologies, that what is Bitcoin and what is cryptocurrency. It is Bitcoin is all about taking money and sending money from one recipient to the other recipients, or we can say that how this blockchain technology can revolutionize, can be used in different applications. That is also one of the key concerns, and what is the overall idea that we have to take care of. So uh, how does the origin of blockchain technology has been there? So it has been observed during the 2000s financial crisis, where we have multiple parties that may consisting of records, and these records are consisting of centralized repository. So if one of those centralized repository fail it out, then whole database may be collapsed, and the whole information would be passed it out. So to how to question came in the mind of researchers, that how to overcome this particular issue. So can we create a replica of the same information at all of these different nodes? So from there onwards, the idea of blockchain comes. So here we have different parties. These different parties have the replica of the same ledger. So this ledger is, let's say, this ledger is just like a database which each party maintains. So let's say party A is there, party B is there. So this also contains the same ledger or same set of what we call as records. This party also contain same set of records in their repository. Similarly, this party also contains same sets of records. Similarly, this party also contains the same replica of the ledgers. And then these ledgers are nothing but these are digital ledgers. So digital ledgers are used to store the information in digitally. Let's say some names are there. Let's say some information associated with that is there. So all these digital information is stored in this distributed ledger. So these ledgers are different. These ledgers are different from the traditional ledger, in the sense that in the traditional ledger we have to kept it as a manual process, and if there is some happening with respect to the loss of records, then that cannot be retrieved. But here in this digital ledger itself, we can retrieve those records, or we can make the timestamp of all those records, which can be maintained in this distributed ledger itself. So from this traditional, we can say architecture, which consisting of a centralized repository where we have to maintain the information in a centralized repository from where if there is some happening or if there is some sort of, we can say, shortcoming, or if there is some sort of failure, we are slowly moving towards this distributed scenario where we have the same replica of ledgers at different locations, and from these different locations we can check it out the fault tolerance, and we can issue various types of other issues in any networks. So the inception of this comes with the first white paper in 2008, that is Bitcoin. So this Bitcoin has been introduced by Satoshi Nakamoto. This is called as peer-to-peer electronic caching system. From there onwards, this technology has been revolutionized, and nowadays it has been used in online trading, in various types of applications where we can use this digital currency. So digital currencies, we can say the most successful among a lot of efforts is Bitcoin. So it replaced the cash with numbers and codes. So you can see that the whole replacement of cash has been done with numbers and code using this Bitcoin protocol. So, but question that comes in our mind is that how does this digital currency has advantage as compared with our traditional cash itself? So you can see that this digital currency had advantage that it is fast, it is internationally recognized, it is easy to maintain, and it doesn't weigh anything, and it is we can say cheap in the sense that we can create our own digital currency and then transfer it to the other persons in equivalent form of cash in his own local currency. So there are problems of digital currency, maybe that it may use a double spending mechanism, that is networks are noisy and transmission in this case. So in a particular case itself, this digital currency, a hacker can capitalize this. There may be some fraud detection may also be there, so there may be some ownership problems, etc., etc. So in a digital era where we are living nowadays, obviously digital currency is the need of the hour, but on the other side it may have some other problems that we need to take care of with respect to the generation of blockchain networks. So how this there will be a road, long road to Bitcoin. So earlier all types of banking was centralized banking mechanism. There was not a robustness mechanism that are associated. So Satoshi determines to find a centralized part of bank, that is a ledger should be there. So he says that if I could turn a bank inside out, instead of one centralized party controlling the ledger, what if every users were recruited to maintain a constantly updated copy? So that from this notion, the evaluation of blockchain technology has been done, and the strength of digital copy was perfect copies. Copy this ledger. So this copy of this ledger will be copied to everywhere, on every each and every node instantly, and any ledger with even one common not agreeing with the masses could be discarded. So there may be replace cash with the ledgers. So those are some mechanism that had been used for the revolutionize of Bitcoin. So this I mean to say here, we are replacing the cash with ledger, and these ledgers are distributed ledgers like in this scenario. So these new networks where we have a distributed ledgers that can be public or private and vary in their structure and size. So there may be a thousand or millions or billions of nodes on a blockchain networks that are interconnected with each others, and they in these users are anonymous, and these users uh, has a copy of the ledgers and participate in confirming the transaction independently uh, on a blockchain networks. So what actually the blockchain is? So we can say In fact, the blockchain is more than a technology. It usually contains financial transactions. So it means to say that, let's say we have one block, then we have a second block, then we have a third block, then we have a fourth block, and all of these blocks are interconnected using some cryptographic mechanism. So using these cryptographic mechanism, these blocks are interconnected with each other. So this block is nothing but, this is just like a function. It contains various types of attributes, and one of those attribute is hash mechanism. That is, hash is nothing but a function, sorry, a number that is associated for identification of any block. So this block has some ID associated with that. We will come to that particular part, but you see that these blocks can be visualized just like a function, and this function has some attributes. So those attributes we will come into the coming slides, and it is just like a chain of blocks that are interconnected with each other, and these chain of blocks are interconnected with each other using cryptographic mechanism. Using those cryptographic mechanism, or we needs to prove the identity, and those identity will be proved with the help of finding out a digital signature that is used to prove the identity, authenticity, and read and write access to every public or private blockchain uh, in any scenario. So we can say that if we talk about a blockchain with respect to database, so Bitcoin store all its transaction on a public database. So that public database is called as a blockchain. Uh, Means it consisting of, it is nothing but it is a public database which is used to store different types of transactions, and these transactions part of different blocks. Like for example, here we have one block that consisting of finite number of transactions. That block also contain finite number of transactions. That block also contains some finite number of transactions, and all these transactions are considered as some sort of data. So for example, let's say one block is consisting of name, age, roll number, and let's say student ID. So these are the some sort of attributes, and let's say I execute one transaction at here. I am reading one newspaper, so this is one transaction, let's say. So this will becomes a part of this block, and then this block also have some block IDs. That block ID is, let's say its block ID is 1, its block ID is 2, its block ID is 3, its block ID is 4, and each of these block has some we can say information that is or transaction that are associated with that, and these becomes a chain of blocks, and the first block of every chain is called as a genesis block, and there is a hash algorithm which will compute a number association for each block, which is to be maintained in these blocks from block number 1 to block number n. In this case specifically, it is block number 1 to block number 4. So I mean to say here that how this blockchain technology will actually work it out. So it's based upon cryptocurrency. So let's say someone requests a transaction. So on this, once someone requested a transaction, so the requested transaction is broadcast to each peer-to-peer networks that consisting of a finite number of computers as a node, and these nodes are all are stakeholder of this of this networks itself. So this transaction which had been generated from this node, once this transaction is passed to this blockchain network, so this node also participate in validation and verification of this transaction. This node also participate, this node also participate, this node also participate, this node, it means to say it is a collection of peer-to-peer network-based mechanism in which if there is some sort of transaction which is generated from the source or from any node or from a user, then it is passed to this blockchain networks, and the validation has to be done it out. So this validation needs to be done it out with respect to designing some sort of smart contract or consensus mechanism. So consensus is nothing but, let's say, in these networks we have 10 nodes association with that, and 5 of them are in the favor of adding this transaction to the part of the blockchain, and 5, let's say 4 of them are not ready to be in the favor of adding this transaction to the part of the blockchain. So it has been observed that if more than 51% of the node are agreed on adding these transactions as a part of the blockchain, then these transaction will become as a part of the blockchain, and then a new block can be created. So this is called as a consensus mechanism, and there are many consensus mechanism using which we can verify and validate uh, the blockchain net. Somebody put some message, let me check it out. Okay. Okay. So this verified, I mean to say here, I hope you are clear about what does it mean by the verification of the no verification of this. Okay, somebody says what are ledgers? So I have already told you ledgers are nothing but these are just like files which are used to keep track of records. Like for example, I have let's say I have I have this node associated that consisting of I mean to say here each of this node consisting of some sort of record keeping. So this node consisting of its own ledger. So ledger is just like a diary, right? Say this diary is consisting of all those transactions which are to be processed by this particular node. Similarly, this node is also consisting of some diary which is used to keep track of that what type of information is to be stored on this particular node. So it is just like a record keeping mechanism. So this is also a record keeping mechanism. This node will also keep track of its own ledger. So ledger is just like a register that old people maintains in the earlier days. So here also the ledger has been maintained by each of these nodes, and using maintenance of ledger by each and every node, they will keep track of how many number of transactions has been committed, or how what it is just like a record keeping mechanism. I hope this point is clear now, everyone. What does it mean by the ledger, right? Then uh, then these verified transactions which had been verified by using some consensus mechanism, so then these verified transactions can involve cryptocurrency contract or other information part, that is let's say its equivalent representation of this currency. Let's say this currency 1 rupees is equal to 48 a cent, or 1 rupees is equal to $48 or something. Any types of equivalent currency would be there, and once these are verified, so these transactions are combined with the other transaction to create a new block of data into this ledger. So ledger is used to keep record of what types of we can say blocks are created, and then this new blocks is added to the existing blockchain, and then we will have the whole we can say transaction is completed from this particular somebody again put some query, let me check it out. So one query came, then in the previous slide you were using the term block, and in this slide you are using the term node. Are both those refer the user using the app? So nodes are the we can say participating entities, and blocks are used to create some useful information, like they contains the data associated with the blockchain, because data consisting of, let's say my name is there, and this data may consisting of some sort of transactions to be executed. Let's say I give one part is that I'm reading a newspaper, so this is maybe one data. I'm executing, I'm transferring money to a particular person, so this is again some sort of transaction associated with the block. So these blocks, how many number of blocks are created in a particular chain itself, that will depend upon some consensus mechanism that will come into the next slide, where we will study that how these blocks are created and maintained in a particular blockchain networks. So I mean to say here, once this like for example here, if we have to add this block as a part of this chain, because these blocks are already verified and tested, so it is peer-to-peer networks, and if we have to add new blockchain new block into this chain, then this block needs to be verified before it goes to the part of the chain, right? So question here arises is that how we can add the block a new block into the blockchain. So there are few concepts that we need to take care of for learning out a blockchain technology. So first is distributed shared ledger. That is I have already explained what does it mean by the ledger. So ledger is just like a record keeping register, which is used to keep track of or used to keep all the transactions record on a particular node itself. And if we have to keep record of that what type of activity or what type of, we can say, how many types of transactions are executed on a blockchain networks, then we need to keep track of all those transactions with respect to the ledger that we have in our repository. Second is we should all be aware of this cryptographic mechanism, that is obviously each block consisting of some hash, a number. That hash is nothing but a number. So how to generate a hash? So there must be some cryptographic algorithm for that. So SHA-256 algorithm has been used for generation of new hash, and hash is nothing but it is a 64 character number, or we can say 256 bits number. That is in each character is encoded into 4 bits. So 64 multiplied by 4, it is SHA-256 we can say hash mechanism has been used for creation of the blockchain. So this number is used to verify that if new block will become as a part of the blockchain or not. If its identity has not been verified, then we cannot add new block into the blockchain. And then obviously we should have some consensus mechanisms is also there. So I have already told you that if, let's say, consensus is nothing but it is just like an agreement. So let's say we are 10 pupils in a particular group, and four out of these 10 pupils, 5 say that we drink coffee and 5 says we drink tea. So at this instance of time, we are having a 50-50 chance that who will win, whether the person who is offering asking for coffee win, or the person who is offering tea will win. So if, let's say, I get one more vote in my favor, and out of these 5 who are offering coffee, I will add it to the tea, then the number of contestants for the tea will become 6, and number of contestants for the coffee will become 4. So out of 10, let's say 6:4 ratio is there. So the person who is offering a tea will win, because there are 6 votes in the favor of the person who is offering tea, and there are 4 votes in the favor of the person who is offering coffee. So I mean to say here, same mechanism can be applied here also. So if we will have 10 nodes in the networks itself, and out of these 10 nodes, let's say 6 nodes are in the favor of adding new nodes or new blocks, then that block can be added into the blockchain. But if we have less number of votes, let's say out of 10 only 4 votes are there, then that block cannot be added as a part of the blockchain. And then there is a smart contract. So smart contract has to be designed in some programming language, where we need to design that what are the attributes needed to create as a part of the blockchain network. So in this scenario, you can see that that we need to write it out smart contract in some programming language, so that smart contract can be written either in Java, or that can be written in other programming languages also. So that we will study, or that we will study when we will do the practical part of this blockchain technology. So in nutshell, we can say that blockchain terminology is basically consisting of, let's say, uh, uh, that we have moved from centralized repository to a distributed repository. So earlier what happens is that we have a centralized repository, let's say municipal corporation house, where we have a clearing house is there. And after this clearing house, if we have to make some sort of bill adjustment, or we have to make some sort of paperwork, so everything will go to this centralized authority, and this centralized authority will prove that what type of facility needs to be offered to its resident in a particular locality, which are located in a particular locality. So it maintains a centralized ledger. That is, somebody again put some query. So he says that node is basically a participant in a network, whereas block is like a small part of the ledger. Here consider a ledger a diary, and a block is a page of ledger. When the block gets full, it moves to the next block. Uh, to some extent, you are right. From Santa, you says that uh, obviously the ledger is just like a diary, and block must be verified with respect to inclusion as a part of the chain. And every block cannot becomes a part of the chain, so it must be verified with respect to inclusion into the blockchain networks. So each block has some ID associated with that. So let's say some block is there. If it has some ID associated with that, it has some data associated with that, it has its own hash value, it has its previous previous block hash ID is also there. So if all of these attributes, previous hash value will match with the current hash value, then only we will say that particular ledger, that particular block is valid. If by changing, or by making some sort of attack on the blockchain, that hash value has been changed it out, then in that case we will easily trace it out, that who has made some mistake, or who has changed the data within that particular block. Because in that case, both the hash value will not be changed, because each block contains the previous hash value, so that previous hash value must match with the current hash value in that particular block. So if an attacker attack on the blockchain networks and change the value of the hash, then that value will not match to the previous hash value, and in that case we will say that there has been some sort of attack on the blockchain network. So it's primitive that we should have I mean to say here, the value association with previous hash value and the current hash, that current block that contains the previous hash value, both should be same. And if by some chance, let's say if by some chance that hash value has been changed it out, so we will came to know that that hash value has been changed it out, and then we will be able to identify that particular culprit, who that culprit is in that particular network itself. I hope this is clear. Is it okay? Okay. Sorry. So I mean to say here that it is based blockchain is based upon distributed ledger technology. So it is just like a distributed database, right? So the distributed database uh, you can consisting of or view as a peer-to-peer technology that is based upon cryptology and certain APIs are there. So uh, uh, the blockchain architecture, this whole blockchain architecture, which consisting of peer-to-peer networks or peer-to-peer technology, where we have a distributed public database. So it consisting of technologies that is associated with it. Certain protocols are there which are used for communication among different entities that are located on the blockchain networks. Like it has TCP/IP protocol, it has HTTP protocols, and there has been a revolutions in the blockchain architecture, starting from blockchain 1.0, where we have a Bitcoin and programmable money is there. Then in blockchain 2.0, where we have smart contract that is based upon Ethereum. Then we have a blockchain 3.0, where we have non-financial users and various applications associated with the blockchain technologies. So uh, the first part that is associated with the Bitcoin system and current banking system is this, that it consisting of a centralized system, that is blockchain system follow a decentralized mechanism. This decentralized mechanism when compared to bank and financial organizations are controlled and governed by central or federal authority. But here in the decentralized mechanism, we do not have any controller. Everybody can participate in consensus mechanism, and in this consensus mechanism, there may be, I mean to say here, every node can be a stakeholder, and it is used to verify and validate the transactions. And everyone who is involved in the system holds some power as a part of decentralized system. And there is a public ledger, this ledger which holds the detail of all the transactions which happen on the blockchain is open and completely accessible to each and every person who is associated within the system. So even though the complete ledger is publicly accessible, the details of the people that are involved in the transactions remain completely anonymous. And verification of every individual transaction has been done in these blockchain networks. So every single transaction is verified by cross-checking this ledger, and validation signal of the transaction is sent after a few minutes. So uses of several complex encryption and hashing algorithms and the issue of double spending is also eliminated in this current decentralized system. And it has low, or I mean to say no transaction fees. So these transaction fees are quite less when compared with the fees that is implied by a bank or other financial organizations. So if a transaction needs to be completed on a priority basis, then additional transaction fee can be added by the user, so as to have the transaction verified on priority basis. So I mean to say here, the key business that has been expanded is using blockchain technologies, that it is time saving, it's cost saving, it has more security and privacy, and it's improve the auditability, and it's increase the operational efficiency of the current banking system using distributed and sustainable ledgers mechanism, which is secure, private, and ineditable. So this is a very ingredient parts, that is whatever the information that is becomes as a part of the blockchain is immutable, and it is transparent and auditable, and it is based upon consensus based mechanism uh, using this blockchain, right? So now we come to the very basic part, that is called as a why it is called as a blockchain. So general question that arise in our mind is what actually the block is there, what should be the structure of a block, and how this becomes a chain of these blocks. So each block is nothing but it is just like a function which consisting of some ID, that is, let's say this is a block ID, block 5, any number, that is, let's say block number 1, block number 2, block number 3, and then each block has some information or each data associated in that particular block, and that data is number of transactions that is to be executed, and each block also have a previous hash value. So hash is nothing but it is used to verify the authenticity of that particular block. So, and each hash has some value. That hash is 64 characters with 4 bits for each character. So it is 256 bit number, that is SHA-256 algorithm has been used to generate the hash value. So this hash value uh, comes from the previous block. Like for example, this block has some hash value, so this is embedded into this block. This hash value has been embedded into this block. So if we start from this side, so there is some hash value that is from previous block. This is the hash value of previous block. This is again becomes the hash value of this block, and this is the previous hash value that becomes to the part of the next block. So each of these hash values, so for example, if an attacker attack on this block and he changed the hash value of this, so this value would be different, and then this value will be matched with this value, so both value would be different. So in that case we will say that this block has been compromised and this whole blockchain has been compromised. So in that case we will say that there has been some attack on this blockchain network. So we will try to find out remedies, or we try to find out the solution that how this attack has been happen on this blockchain networks. So if this previous block hash value will not match with the this particular attribute, in that case we will say that there has been some attack on the networks. So if this hash value has been changed, then this hash value, next hash value of the next block would also change, hash value of next block would also change, hash value of next block would also change. So I mean to say here, because each of these chain will continue, so these value will change continuously from one domain to another domain. So it will be very difficult for the attacker to launch an attack for from one domain to another domain, so that the so that I mean to say here, so that we can launch types of attack in the networks itself, right? Hello. So here I'm giving you one more thing to explore. So you can see that I am adding some value. Let's say I am Neeraj. So you can see, so we are generating some hash value here, right? For example, at here. So while this we are using this SHA-256 hash. So you can see if I'm changing even a single character, then we have a different hash value for this particular we can say data. So this data is nothing but it is a value associated in a particular block, and if we are going to change it out, you can just visualize that if we are going to change it out, this value, let's say I am giving a lecture, so you can check it out that how this hash value has been changed it out. So if we just change one character also, then you can see we have a different hash value in a particular block. So using this SHA-256 hash, we are generating a different hash value. So this is the beauty of this blockchain networks, that if we change only, let's say, if we change even a single character, then this whole we can say hash has been changed it out. So we can have a block structure like this. Let's say we have this number association with a particular block, then we have a nonce associated with a block, and if we entering some information, so you can check it out that I am entering some information in this block. So you can check it out that the hash value has been changed it out as soon as we add some value in that particular block itself. So this is the beauty of this blockchain, that we can uh, I mean to say here we can change this value, and using this value we can explore that how much reliable this is with respect to inclusion of a particular block in a blockchain network. So we come back again to the slide mode. So I'm dictating this point here, that if some attacker has to launch some attack, then in that case what will happen, that he has to, let's say some attacker has launched some attack on this particular block, so he has to change all the hash value of the next preceding we can say blocks. And in a particular chain there may be a millions or billions of blocks, it's very difficult for him to attack or compromise all the blocks in a particular blockchain. So that's why it's a very safe and secure mechanism in a blockchain networks. So there are different players that are used in blockchain users. One is blockchain users, blockchain developer, blockchain network operator. There may be a different processing platform that may be used for processing out the blockchain information. So data sources, certification authorities. So how does this distributed ledger work it out? So distributed ledgers are nothing but that are used to store some information in the blockchain network. So what are the various types of operations that needs to be performed in the blockchain network? So you see that first the user initiate the transactions using their digital signatures. So we have to create our own digital signatures. These digital signatures, using those digital signature, user initiate their transactions, and then they broadcast their transaction to the nodes. So one or more node begin validate those transactions, because each of these transactions which are supposed to become as a part of the block needs to be verified, and then each nodes aggregate the validated transactions and form them into the blocks, and then these nodes broadcast the block to each other, and using those consensus protocols, and this new block will become as a part of the blockchain. So I hope this is a very simple and straightforward process. I hope you are clear that how the chain would going on expansion, and how the chain expands from one node to another nodes as a part of this distributed ledgers, and how these distributed ledgers are used to becomes as a part of the blockchain networks. So as I have already told that in the traditional system, you see that ledger has been maintained like this, like we have name, we have his, we can say distributed, we have some entries associated with that. But now this ledger, which is nothing but a database, has been replaced by digital ledgers. These digital ledgers are used to keep track of uh, the blockchain networks. So that this decentralized ledger is a part of the blockchain, because it is get rid of third party. So earlier what happens is that whenever we have to make certain conversation with the other nodes, so we need to take care of the permission from the centralized authority, but this centralized authority may be overloaded, or this centralized authority may have some fault, or that may have crashed it out. So during this scenario, there may be chances that we are not able to cope up with this decentralized mechanism. So to cope up with this, we come with decentralized mechanism instead of a centralized ledger mechanism. So earlier it was happened that it is based upon various types of cryptographic mechanisms. So there is a history of this cryptographic mechanism that was uh, association in the earlier part. The revolution started back in 1980s, where we have a where we have a public key cryptographic algorithms. Then we have in 1991 some cryptographic timestamp comes into play. And then in 1992 we have proof of work has been there, and then in 97 hash cache mechanism was involved. Then bit gold, then B money, peer-to-peer networks, then Byzantine fault tolerance, and then in 2001 SHA-256 was finalized. So this SHA-256 bit protocol has been used for generation of digital for hashing mechanism, which has been used for verification of the transactions. So this blockchain technologies back in 2019, back in 2009 to 2012, there was some foundations there. Then we are moving beyond this cryptographers, rise of Bitcoin exchange between 2012 to 2014. Then from 2014 to 2015, there was a blockchain buzz year was revolutionized. Then in 2016 to 2017, we have crossing this jam, and 2018 to 2020 adaptation of movement, and finally, and we have this accelerated adoption of this blockchain technology across the globes. So you see that there may be a different types of blocks that may be associated as a part of the chain of blocks in the blockchain technology, but what are the components of a particular block? So there, first of all, you see that the structure of any block is started with the version information, or we can say the block number is there. Then we have some nonce is there. So nonce is a random number which is used to generate a number association in a particular block, and it also have the previous block, we can say hash, and then we have a timestamp, and using this timestamp we can be able to find it out when and where that block has been, or when and where those transaction has been executed. So as I have already told that the transactions and in a block is a nothing but block is a collection of transactions on the Bitcoin networks. These are gathered into blocks that are hashed and added to the blockchain networks, and each block has some ID association with that, like block number 51, block number 52, block number 53, and then there must be some hash association. So that hash is again 256 bit number, and it also has a previous hash and some nonce, as I have already illustrated you an example. So the next part that is associated in a blockchain networks is mining. So the mining is nothing but this process of solving some cryptographic problem using computer hardware. So it's consisting of finding out some sort of consensus in a blockchain networks. That is how mining is nothing but there is some sort of threshold that is set it out. So for each corresponding to each nonce, we will generate some hash value, and our task in mining process is that who will becomes, which are the transactions which are supposed to becomes in a blockchain as a part of the block in a blockchain networks. So mining is all about solving those cryptographic puzzles in a blockchain networks. So the process by which transactions are verified and added to in a blockchain, that is becomes a process which is called as a mining, because you see that each of these transactions may not becomes as a part of the blockchain. So mining is nothing but it's all about how to verify the transactions which are supposed to becomes as a part of the blockchain. So you see that out of these number of transactions, there are only few number of transactions which are supposed to become as a part of the blockchain. So those transactions are verified or mined by some miners using an algorithm. Using that algorithm, miner will verify that those transactions will become as a part of the blockchain network. So blockchain, in this particular part, you can see that each of the transactions may not become as a part of blockchains. So only those transactions which are supposed to become as a part of verification process will becomes as a part of the blockchain networks. So miners on the network select the transactions from the pools and form them into the block. So this question here is that which transaction should I add to my block? This is a very general question. So this is a very general question in the sense that all transaction cannot becomes uh, uh, as a all transactions cannot becomes a part of the block. So only few transactions will becomes as a part of we can say blockchain networks. Somebody put a question that is there any minimum and maximum size limit of single block? So there is no limit that how many number of transaction will become as a part of the blockchain. So because you see there are billions of transactions that are needs to be part of a block, but only thing that needs to be taken care of is that how many number of what transaction should become as a part of the blockchain. So key question here arises is that how you will verify that which transactions should become as a part of a block which is supposed to become as a part of the blockchain. So that is the task of these miners, and we needs to set out some criteria based upon which we need to verify and validate the transactions that should becomes as a part of the blockchain networks, right? So let's say we have set out some threshold and we generate the hash value using SHA-256, and using those nonce, as I have already told you that let's say we go to this part, I think this one, yeah. So this nonce is there. So we apply the hash algorithm on this nonce and get some hash value. So we after applying this hash value to these nonce, we get some hash value. After applying hash algorithm, we will get some hash value, and then these hash values are put in some order. So using those hash values, we will be able to decide that which transaction should becomes as a part of the block, and then add those transactions into these blocks, and then the size of collect those all those we can say transactions in a particular block, then verify those blocks with the help of consensus algorithm, and then set out those consensus set out those we can say blocks as a part of the blockchain networks, right? So the second terminology that had been used in this case is fork. So fork is a creation of alternative version of blockchain by creating two blocks simultaneously on different parts of the network. So that may be possible that because you see that each of these nodes contain the same replica of blockchain and different parts. So if we have created two blocks simultaneously at somebody wants to say, because you want to say something? Okay, so it creates two parallel blockchain where one of those is a winning blockchain in terms of that it has more computing power or more consensus algorithm or more votes as compared with the other blockchain. Because you see, if we create two blockchain simultaneously, then one of those blockchain may not be valid and other blockchain may be a valid blockchain because of the number of we can say higher number of votes or consensus as compared with the previous blockchain. So if this happen, then what should we do? What does it happen? So block there may be simultaneously block and we at that particular instance of time we needs to fork it out or we needs to make a winner from this blockchain, because you see that winner consisting of some sort of number of blocks which needs to be replicated on different nodes in the blockchain network. So that's why you can see that if there are multiple blockchain that may arises in the networks, then that must be replicated, data must be replicated on different blockchains simultaneously in a blockchain networks. So based upon these concepts, the first we can say cryptocurrency that was developed by Satoshi Nakamoto in 2008 was Bitcoin. That is cryptocurrency, that is first asset based on blockchain, that is used for drug, weapon, e-commerce or ransomware, and it's used for remittances and other parts across the world. So nowadays you can see that blockchain has been revolutionized across the globe. So this Bitcoin consisting of let's say a block is there, it consisting of a header value, then we have some transaction count, that is how many transactions are there in a particular block, that is including the coin based transactions, and then actual block contents, that is how many number of transactions, then these hash value, previous hash value that are there for the blockchain network. So inside this blockchain inside this Bitcoin blockchain, that is a block header is there and it has different attributes associated like this, that consisting of block hash, Merkle root, timestamp, nonce. So that is the example of this Bitcoin part, that is previous hash is also there, and current hash value is also there, version is there, and and the other attributes that are associated in a blockchain network, in a Bitcoin part itself. So for example, uh, if we will have a mining coin base that is used in Bitcoin, so from this mining base it is used to check it out the send used to check out the regulation flow between sender and receivers using some Bitcoin. Let's say 50 Bitcoins are there, so these Bitcoins are used to be transmitted or distributed to different we can say recipients in these blockchain networks. So actually what happens is that there is a transfer of equivalent money or equivalent Bitcoin to a sender and well as receivers. So how this process will start it out? So first of all, let's say this is our starting process and this is our ending process. In between this process, let's say some person open a Bitcoin wallet and then he scan a QR code using some address association with that, and then fill up the amount and fee for using Bitcoin, and then send to the other users. From the other users, the wallet signs the transaction using this person's private key, and this transaction is propagated and validated by the network node, and then miners include the transaction in the block to be mined it out, and then there is some mining time associated. Mining is some computational process of calculating the hash value. So once this hash value has been computed, so the miner who solves the proof of work propagates the new block to the networks, and then this node verifies the result and propagates the blocks, and finally when this confirmation has been ended and the process will be ended. So it means to say, starting from this source to this end, we have some complex operations to be performed, and these complex operations are nothing but performing consensus algorithm, then generating hash values, and then verify those transactions which are supposed to become the part of the block, and then each blocks will be verified and validated, and then these blocks are supposed to become as a part of this blockchain networks in a synchronized manner. So this is the whole process that is to be followed in a blockchain network. So the consensus mechanism that is used in a blockchain networks is based upon Ethereum. That is one of the most important part is write out the smart contract based mechanism, and the Ethereum smart contract has been used to verify and validate the transactions which are used to become as a part of the blockchain network. So you see, this Ethereum was proposed back in 2013 by Vitalik Buterin, so cryptographic researchers and programming, who is used blockchain as a magic computer that anyone can upload the program and leave the program to self-execute, where the current and all previous states of every program are always publicly visible, and which carries a very strong cryptoeconomically secure guarantee that program running on the chain will continue to execute in exactly the way the blockchain protocol specifies. So this Ethereum is based upon decentralized app platform, and it is based upon transaction and smart contract ledgers like here. So this is decentralized mechanism, and it's based upon Ethereum virtual machines, and it consisting of cryptographic or cryptocurrency that is called as ethers. So you see that there are two types of contracts that can be used. So one is paper-based contract, second is a smart contract. So you see that in the contract-based mechanism, first we need to define yeah, what contracts we need to sign it out using some pen and paper, and then we need to audit that contract, and finally there is some legal binding association with this. But this contract needs to be make smart, because in this case this whole process which is to be executed between two parties, that needs to be digitally signed, or that needs to be a legal document. So that's why all these smart contract is all based upon now smart, with the help of smart software programs like definitions, like auditing, real-time immutable part, then programs, all these we can say life cycle of any smart contract that is needs to be maintained by these participating entities, and these participating entities will perform the task of smart contract design between two parties which are abide by the rules and regulations, and it is fully made secure and cryptographically secure, and can be used for any legal bounding between two parties. So how this was the basic terminologies of blockchain technology, and more or less we can say how we can make a distinction between database and blockchain ledgers. So database is based upon this centralized repository based mechanism, while in this case of blockchain ledgers we have different clients. Each of these clients can maintain its own ledger. So it's not about centralized authority, it's all about distributed architecture. But here we'll have centralized repository, which is to be accessed by different parties from different locations. So if we have to make a distinction between database and blockchain, so database have administration and centralized control, but here there is no administration, and it is fully decentralized mechanism based upon fully decentralized mechanism. Here only the entities with the right can access the database. Here anyone can access this blockchain networks. Here only the entities entitled to read or write can do so, but here anyone with right proof of work can write on the blockchain. And these database are fast and blockchains are a little slow, because we have to make proof of work, verify and validate all those transactions which are supposed to become as a part of the blockchain. And here we have no history of record or ownership of digital record, but here we have history of record and ownership of digital records must be there. So there are some cryptographic components that are associated in a blockchain networks. So two types of cryptographic mechanisms are used in a blockchain networks. One is hashing, second is digital signature. So there are three forms of encryptions that are widely used: symmetric encryption, asymmetric encryption, and hashing mechanism. Symmetric is a two-way function, that is same password is used for encryption and decryption, while in case of asymmetric, it is one password is used to encrypt or decrypt the message, and this password comes by pair. And in case of hashing, it maps to a fixed size data, and it is based upon a one-way hash function. So let's say we have some information, hello is to be sent it out using symmetric encryption. So this is based upon some key, that is one key is used by for encryption and another is used for decryption, right? And in case of asymmetric, we have one key which is used for um, make out this encryption and decryption mechanisms. While you can see that in case of hash mechanism, it is some hash algorithm has to be applied. Sorry, here we have some public and private key cryptographic notions. Here we have some symmetric key encryption, same key that have been used for this purpose. Here we have to generate two key, one is public and private. So in this case, you can see that using this hash algorithms, we have to generate a fixed size digest for this particular message. So once we have entered this message, so a fixed size, we can say, message digest has been generated. So like for example, here we have some public key association with that, and then we have some private key which is used to generate the original message from this encryption or decryption mechanism. Like we have this hello message, apply the hash algorithm, and then we have the cryptographic hash association with that. So I mean to say here, till now, any question from your side? Hello?
Yes, Neeraj sir.
Yeah.
This is Dr. Mukesh sir. Uh,
Yes, please, sir.
yes, Neeraj sir. You may take the rest for 5 or 10 minutes. Meanwhile, you can say after 5 or 10 minutes, it really will be a better thing just to interact with the audience. If they are having any question or any doubt regarding the material covered till time, then it will be a great thing.
Okay, so should I interact now or should I continue now?
As per your wish, sir, if you want to have a rest for 5 or 10 minutes, then you may have. And after 5 or 10 minutes, the audience, if they are having question or any doubt, they may directly switch on their mics and even their video also, and they may interact.
Okay.
So you are going to take rest, sir, 5 or 10 minutes?
No, it's okay.
Okay.
So audience can ask the questions if they have any.
Okay.
So because rest of the slides we can cover tomorrow.
Okay, that's fine, sir. Fine. So, audience or participants, you are most welcome to just switch on your mic and videos and ask questions or any doubts regarding the material covered till time. Yeah, please. Macweer, you may just switch on your mic and ask. Macweer, sir. Yes.
Yes, sir.
Yeah, please ask.
Sir, like miners are given a reward in the form of Bitcoin. That is also verified.
Yes. I mean to say here that miners needs to do a lot of hard work because you see they have to do a lot of hard work for verification and validation of different transactions. So they must be given some rewards in terms of Bitcoin. So those needs to be verified in terms of I mean that is not a fixed quantity, but that needs to be verified.
Okay, sir.
I have a question.
Yeah.
Santa this side. I have a question. You said in one of the slides you said that Bitcoin has one of its aspects that the fees for the validation of a transaction are usually low or no fees. But as we can see in practical situations, currently for a single Bitcoin transaction, the fee is around 60 United States dollars. So like that is quite big. So I mean, how is that? What's up with that?
You see, it is a very complex process because you see, each transaction needs to be verified and validated by miners because these, as I have already told you, that miners needs to verify and validate the transaction, and it is a huge task because to verify the transactions from billions of transactions, it is a very tedious task for finding out proof work and proof of consensus mechanism. So $60 you have already told that is it all depends upon how much reward you want to give to a particular miner itself. So yes, you are right that $60 is a bit huge amount, but this needs to be I mean to say here, this needs to be verified and validated as per the requirement of the miner, that how much fees he will charge as far as the transactions verification and validations are concerned. Any other query? Somebody says, is cryptography or hashing same thing? I don't think these are same thing. Hashing is one of the part of the cryptography. Cryptography consisting of symmetric key and asymmetric key generation, hashing, and digital signature generation. There are a lot of concepts or lot of attributes that needs to be there for cryptography and hashing mechanism. Then somebody, Anju, says that how many blocks can be part of the ledger, because for banking scenario this chain keeps on increasing with time. Yes, you are right. There is no limitation in terms of how many number of blocks that can be part of the ledger, because each blocks consisting of billions or millions of transactions that needs to be there, and each of these transactions needs to be verified and validated before they becomes actually the part of any blockchain networks.
So I request you all again to please switch on your mic and ask verbally. And if possible, you may also switch on your videos, because we are going to remain together for the next 1 month. So let us start interacting. Yeah, Sanket. Will you please switch on your mic, Sanket, and then ask?
हेलो।
हाँ जी, जी संकेत।
ये सर जैसे क्रिप्टो में सर हैशिंग यूज करते हैं तो सर उसमें हमारे पास एक 256 बिट का कोड होता है जो जनरेट होता है। तो लेकिन सर इससे पहले जो हमारे पास प्रीवियस इंक्रिप्शन टेक्निक्स थी सर, उसमें और हैशिंग में क्या डिफरेंस?
नहीं, मुझे क्वेश्चन क्लियर नहीं हुआ संकेत, आपका क्वेश्चन क्लियर नहीं हुआ, क्या कह रहे हैं आप?
सर प्रीवियस इंक्रिप्शन टेक्निक्स जो होती हैं, जो हम लोग यूज करते हैं कोई भी ट्रांजैक्शन करने में, जैसे हम लोग कभी भी ऑनलाइन करते हैं तो उसमें 128 बिट या 256 बिट का एक पेज जनरेट होता है। और सर हैशिंग में और उस इंक्रिप्शन मेथड में क्या डिफरेंस होता है?
हैशिंग तो बेसिकली एक नंबर हुआ ना, कि आर्बिट्रेरी लार्ज नंबर को आप एक फिक्स साइज डाइजेस्ट में कन्वर्ट कर रहे हो, है ना। हैशिंग इज बेसिकली यूज फॉर जस्ट लाइक ए कोड फॉर वेरिफिकेशन एंड वैलिडेशन पर्पसेस। लेकिन जो ओरिजिनल आरएसए है, या आपका जो एलिप्टिकल कर्व है, या जितने भी टाइप्स के क्रिप्टोग्राफिक मैकेनिज्म है, वो आपके डिजिटल सिग्नेचर्स यूज करने के लिए यूज होते हैं। तो उनके ऊपर हमने कोई रिस्ट्रिक्शन नहीं लगाई हुई इस तरह की। वो डिजिटल सिग्नेचर अगर आपने जनरेशन कराने हैं तो आप क्रिप्टोग्राफिक जो कीज हैं वो यूज करते हैं आप लोग जनरेशन के लिए, है ना। लेकिन जब आप हैशिंग की बात कर, हैशिंग हम जस्ट एक नंबर जनरेट कराते हैं जो वेरिफिकेशन और वैलिडेशन में यूज होता है, कि भाई आपका जो ब्लॉक में जितनी भी ट्रांजेक्शन्स हैं वो वैलिड हैं या नहीं है, या कोई अटैक लॉन्च हुआ है या नहीं है। दूसरी बात, हैशिंग जो होगा वो एक फिक्स साइज डाइजेस्ट जनरेट करने के लिए यूज होता है फ्रॉम आर्बिट्रेरी लेंथ ऑफ द इनपुट डाटा स्ट्रिंग।
Sir, as you said that ledgers are the kind of file that consisting of all kind of data, and blocks also contain data. So what is the basic difference between ledger and blocks?
नहीं, देखिए, ब्लॉक में क्या रहेगा, ब्लॉक के कुछ एट्रीब्यूट्स रहेंगे, है ना। ब्लॉक्स के एट्रीब्यूट्स में क्या रहेगा, आपके पास ब्लॉक आईडी रहेगा, नॉन्स रहेगा, डाटा रहेगा, और प्रीवियस हैश और करंट हैश, ठीक है। अब ये ब्लॉक एक पूरी ब्लॉकचेन का पार्ट बनेगा, ठीक है। और वो लेजर क्या करेगा, सिर्फ ट्रांजेक्शन कितनी हुई है उस पर्टिकुलर ब्लॉक में उनका रिकॉर्ड रखेगा, ठीक है। तो लेजर इज जस्ट लाइक record keeping of number of transactions, but block consisting of not only transactions, block id, hash, previous hash, nonce, etc, etc.
Thank you, sir.
The attendance link has been shared in the chat box. So all are requested to mark their attendance within next 10 minutes. Yes, please.
Good evening, sir. My name is Nitin. Sir, I would like to ask, there is no key used in hashing. So what prevents the hacker from manipulating the hash in the block? Like if I am a hacker, I can manipulate the block, manipulate the transaction, and then hash it and place the hash inside the block, and then transmit it over all the nodes.
वेरी गुड क्वेश्चन, वेरी गुड क्वेश्चन। इसमें ये होगा ना, देखो, जो एक ब्लॉक में क्या होगा, प्रीवियस हैश वैल्यू होगी, ठीक है। अगर अटैकर ने उसको अटैक भी कर लिया तो वो प्रीवियस हैश की वैल्यू और जो करंट ब्लॉक में प्रीवियस हैश की वैल्यू दोनों डिफर हो जाएंगी ना।
Sir,
करंट ब्लॉक में देखो एट्रीब्यूट भी रहेगा ना प्रीवियस हैश की वैल्यू का, ठीक है। तो उसने लॉन्च किया अटैक तो उस हैश वैल्यू को चेंज कर लिया, ठीक है। तो वो वाली वैल्यू और जो प्रीवियस वाली वैल्यू दोनों डिफर हो जाएंगी ना।
okay, sir. Right, sir.
फिर दोनों डिफर होंगी तो हमें पता चल जाएगा कि अटैक लॉन्च हुआ है। तो उसके बाद क्या होगा, जिस ब्लॉक पे अटैक लॉन्च हुआ है, जिस ब्लॉक पे अटैक लॉन्च हुआ है उसके जितने भी आगे वाले ब्लॉक हैं वो सारे भी क्या हो जाएंगे, इनवैलिड हो जाएंगे।
सर अगर कोई आगे ब्लॉक ही ना हो, मतलब तो फिर प्रीवियस हैश वैल्यू की वैल्यू नल होगी, मतलब जीरो होगी।
प्रीवियस हैश वैल्यू जो होगी करंट ब्लॉक में इंक्लूड होगी ना।
Yes, sir. Sir, अगर ब्लॉक की
आपने करंट ब्लॉक के ऊपर अटैक लॉन्च करके उस वैल्यू को चेंज कर दिया। करंट ब्लॉक के ऊपर जो वैल्यू है प्रीवियस हैश की वो चेंज होगी, और प्रीवियस हैश में जो एक्चुअल वैल्यू है दोनों वैल्यू डिफर कर जाएंगी ना।
sir, let's say there is no transaction happening in the world.
हैं?
So no transaction is happening in the world right now. Let's say. So, but there will be no block transmission. So the recent block that would, what would be the value of previous hash value in that?
नहीं, पहले ब्लॉक में तो उसको जेनेसिस ब्लॉक बोलेंगे, पहले वाले ब्लॉक, ओनली वन ब्लॉक है ना। उसके
Yes, sir.
बाद जितनी भी चेन बनती चली जाएगी उसमें प्रीवियस हैश की वैल्यू डलती रहेगी।
सर लेट्स से हमारे पास 500 ट्रांजैक्शंस है, उसके लिए 5000 ब्लॉक्स बना दिए। सर 5000 ब्लॉक्स ट्रांसमिट हो गए सारी जगह, वो सारे ओरिजिनल थे बिल्कुल सही। सर जो लास्ट वाला ब्लॉक होगा उसमें क्या होगा?
लास्ट वाले ब्लॉक में 499 का हैश वैल्यू होगा ना।
ठीक है सर। सर और
और
फिर बिल्कुल फर्स्ट वाले में, उसमें तो उसके पीछे का कुछ होगा ही नहीं।
फर्स्ट वाले में तो सिर्फ उसकी करंट हैश वैल्यू होगी ना।
हाँ जी। तो फिर सर अगर मैं वही वाले से मैनिपुलेट करना शुरू कर दूं और नेक्स्ट सारी ट्रांजैक्शंस खराब कर दूं?
हाँ हाँ, तो फिर पहले ब्लॉक के ऊपर आपने अटैक लॉन्च कर दिया।
यस सर।
ठीक है, पहले ब्लॉक के ऊपर लॉन्च किया तो सारी की सारी चेन इनवैलिड हो जाएगी, आगे कोई ट्रांजेक्शन ही नहीं होगी, क्योंकि हर एक के पास एक एक कॉपी पड़ी है ना। हर एक नोड के पास एक एक पूरी ब्लॉकचेन की कॉपी पड़ी है ना, तो वहां से वेरीफाई करेंगे कंसेंसस से, एल्गोरिदम से, है ना। तो फिर उस केस में अगर मुझे वोट नहीं मिला 10 में से, लेट से मेरे पास 5 वोट्स नहीं आए, तो मैं उसका पार्ट बन ही नहीं सकता। 51% तो मुझे चाहिएगा ना कंटेंट,
ठीक है सर।
है ना। ओके,
थैंक यू सर।
थैंक यू।
Sir, one query I have. Sir, can we use blockchain along with the Hadoop platform? Any example?
नहीं, Hadoop इज डिस्ट्रीब्यूटेड फाइल सिस्टम।
Yes.
तो Hadoop में मैप प्रोड्यूस ही यूज करना है ना आपने।
Is there any example where in combined manner we can utilize any application where we can utilize distributed file systems along with distributed systems along with the blockchain, so that we can in some combination, if there is example, so that we can.
एग्जाम देखिए ना, आप ब्लॉकचेन के अंदर जो ब्लॉक होगा उसके अंदर डाटा है आपके पास, है ना। अब वो डाटा के अंदर आप मैनिपुलेशन कैसे करते हो, दैट इज नॉट अ कंसर्न ऑफ ब्लॉकचेन। ब्लॉकचेन का कंसर्न ये रहेगा कि आपके पास जो डाटा है दैट इज नीड टू बी मेड सिक्योर। अब उसने हडूप के अंदर आपने चाहे मैनिपुलेशन की है डाटा की, या उसके ऊपर कोई क्वेरी लगाई है, दैट यू कैन एम्बेड ए पाथ ऑफ द फंक्शन इन दिस ब्लॉकचेन ब्लॉक। आप पहले उसको हडूप मैप प्रोड्यूस करके उसके अंदर जो डाटा है वो उसको एनालिटिक्स करके देन यू विल थ्रो दैट पर्टिकुलर डाटा इनटू दिस पार्ट ऑफ दिस ब्लॉकचेन ट्रांजैक्शंस।
Okay, that's great. Thank you.
हाँ, ओके, थैंक यू। ओके देन मुकेश, थैंक यू।
जी नीरज सर, that really was a very interactive session throughout 1.5 hour and more than that. We really are very happy to have your session, and really of the same kind of energy, same kind of interaction throughout this month. Thank you very much, sir.
Thank you.
We'll see you tomorrow.
Okay.
So, thank you, sir. Thank you.
Thank you.
So all the participants are requested to mark their attendance, and they may leave also. If you have any theory regarding organization of this course or something else, except the technical content, then you may share it here. किसी की कोई और query or regarding anything regarding the course, except technical, then you may ask.
Yes, sir. Other than technical, how to mark attendance? That I had not attended the last lecture.
लास्ट लेक्चर में अभी तक हमने एक ही अभी चैट बॉक्स में लिंक शेयर किया है गूगल शीट का, गूगल डॉक, तो उस पे आप अभी भी एक्टिव है, वहां पे अटेंडेंस मार्क कर दीजिए, फिल कर दीजिए।
राइट सर, राइट, थैंक यू।
और हमारा डेली रूटीन यही रहेगा दैट with some random proportion of time we are going to share the attendance link in the chat box, so every day if the participants need to mark their attendance.
Thank you, sir.
Most welcome.
Excuse me, sir.
जी
Sir, I had a query. Like tomorrow we have our exam at this time of the session. So can we get the link to the recorded session for tomorrow?
Listen, I am just reiterating that every day after completion of the session we are going to put in on our YouTube channel, and the link will be shared in the WhatsApp group on the
Okay,
next
sir.
day or in the night also, if that completes in time. तो आज रात को या फिर कल मॉर्निंग में लिंक आपके व्हाट्सएप ग्रुप में आ जाएगा. फ्रॉम देयर ऑन यू कैन जस्ट गो थ्रू द कंटेंट.
Okay, sir. Thank you so much, sir.
So where can I find the slides which were shared during the session?
Actually, Dr. Neeraj has just left, so you need to ask this question to him.
Okay, sir.
Actually, he is going to provide the slides or other material.
Okay, so I'll ask him tomorrow.
Okay, fine. बच्चों, it will be
Thank you,
better
sir.
if
Goodbye.
yeah, thank you. So आप instead of writing in the chat box, please switch on your mic and then ask. That will be more convenient. और roll numbers जिनको आपने नहीं पता है, please once again check the Excel sheet shared in the group, and also send with the selection mail. तो उसमें हमने roll numbers allot किए हुए हैं. You need to stick to the roll numbers.
Sir, I'm not added in the WhatsApp group. Can you please add?
Sakshi, please add him.
Sir, I'll add him.
So Sakshi, you will be looking up that.
Sir, I did not get my roll number in my mail. There was it was written there that we have attached the roll number sheet there, but it's
Well, again circulate the mail then. I'll again circulate the same mail.
okay. Thank you, ma'am.
Well,
Excuse me, sir. Sir, I wasn't added in the WhatsApp group.
Sakshi, please look all these cases.
okay, sir.
Akshat, keep in touch with Sakshi. She will be getting it through.
Okay, sir.
Sir, I don't have any roll number list attached to my email, and I was just added to the WhatsApp group.
In the WhatsApp group, the same Excel sheet has been shared, but still, again share the email with you with the updated sheet. Is there anyone else who haven't got the mail regarding the roll numbers?
Yes, ma'am.
Okay. So for those who haven't got the mail regarding the roll numbers, I'll again circulate the mail with the roll numbers.
I will be sending an email to add me to the WhatsApp group.
Sure. Just send me an email. I'll reply over there.
Okay, thank you.
Welcome.
So that's it. Good evening and have a good day. Enjoy. We'll see you tomorrow. All. Thanks a lot.
So thank you everyone. I do mark your attendance.